Especially based on some of the folks that have talked already today, I almost feel somewhat inadequate from the standpoint of Roscoe Bridge. Our primary focus are on short span, simple bridge for rural applications. Now you might sit there and you say, well, you know, is that driven off a location, driven off a business plan, driven off of what? And generally speaking, it's both. We're located in western Montana. You can't get much more rural than Montana. Let me just remind folks that in all of Montana, there's less than 1 million folks. And in a rural county in Montana, I'll just pick a couple, as Sweetgrass County is 1,200 people. I think Carbon County is 600 people. And unfortunately, for Montana, there's quite a bit of roadway. A lot of it's unpaved, a lot of it's gravel, a lot of it is paved. But when you get one of these rural counties and they've got to replace bridges that have been put in all the way back again into the 1800s, but most definitely in 1920s, 30s, and 40s, they're looking for some low-cost solutions that are still safe, well-engineered, et cetera. And that's what we're focused on trying to provide. Not that other folks aren't focused on that same thing, but do be aware that's the thrust of what I'm going to be presenting. Real quickly, we'll just sit there and talk, what is a design-build modular steel bridge? There's a couple folks that have kind of touched on it here real quickly, but I'll talk about real quick that value proposition, modular steel bridge family of products, kind of where they fit in, and then modular vehicle bridges, and that's typically what we're looking at, or I'm going to be presenting today. What I call the best of both worlds. Essentially, we're here under the framework of AISI as Iron and Steel Institute, but quite frankly, there's better applications for steel, there's better applications for concrete, and I think we've all talked. There's been picture after picture after picture shared this morning where you've got steel structure and a concrete road surface. And that might be kind of the default for all of you guys, but I'll sit there and tell you out west that hasn't been our default at all, and I'll show you why. And then what we as Roscoe Bridge, and I think the industry is going towards, because of the requirements of needing a low-cost, simple solution for rural county and a kind of group county. It's state, city, public works, as well as private in there also. First of all, design build. Essentially what we're talking about here, and that doesn't, those of us that are in the design build bridge business, and I think US Bridge, you consider yourself design build bridge builders, right? And Wheeler Bridge, another member of the Short Span Steel Bridge Initiative, Big R, Roscoe, we're design build bridge folks, where essentially, that's not to say we're a cut above or beneath, it just says, you guys as a potential end user or as a consultant are looking for us to sit there and you give us the general spec, the general application for the span, the load rating, and you say, here, you design the bridge, you're responsible for making sure that it's appropriately engineered and fit to the right application. So essentially what that does is it gives us, as design build bridge folks, the ability to reduce some design costs, because the bridge that you might be putting in XYZ County here in Indiana may be essentially, not exactly, but 80 to 90% similar to that same 60-foot bridge that will also be supplying to Missouri, or will be supplying in Montana, or will be supplying in Washington. So why pay for unique engineering for something that's essentially going to be a lot of cut and paste with a certain amount of application unique specific to the site? What that does is it gives us, as design build bridge folks, the ability to sit there and inventory material, because we can design to standards. It's essentially what what Dan had said earlier today is one of the missions of the Short Span Steel Bridge Initiative is to sit there and standardize so that you know that an HL93 vehicle load rating for a 60-foot bridge can always use in the case of, and I just use as an example, maybe it's a 30 by 99 weathering steel beam if it's weathering steel, or if it's non-weathering, it would take the same beam and non-weathering because the strength are the same. So it gives us the capability of being able to support either a DOT in a state application, a county in those applications, or a private customer, the ability to sit there, stock, use those advantages to pass on savings to essentially the marketplace, as well as help us be profitable and long term, i.e. not turn out like a GM. And have this engineering, since it's done once right up front, we can sit there and as design build folks take it to each of the state DOTs, each of the state and or federal agencies, and have them pre-approved so that you, as if you are in fact a county, you can sit there and you know you've got something that is going to receive the blessing from the consulting engineer that you may be using for the overall project and all the approach work and the civil, as well as all the way up through any approval agency, either at the county or state level. And it gives you as an end user and or the consultant the ability, single point accountability, so that you or they aren't having to go out and manage a fabricator, a design engineer, an inspector. It rolls it all into single point accountability. So it truly is a value proposition for the end user. And to me is one of the real main benefits of design build is the time to completion. Is essentially, since you're taking something that's already been engineered 80 to 90% already for somebody else, it doesn't take nearly as much time to tweak it for the unique application, as well as work it all the way through the approval process, because generally it's pre-approved. We'll figure out the ups and downs here shortly. The modular steel bridge. What is a modular steel bridge a la Western Montana style? Well, in the past is we've got vehicle and pedestrian type bridges. Now essentially the way that we've really looked at it in the past is most of our truss bridges are for pedestrian applications. We've got all sorts of applications where we have truss bridges in vehicle with vehicle load ratings too. But essentially what we've done is, again, standardized to the point of true efficiency. It doesn't say that in the case of a vehicle bridge, beam bridges are always the value proposition, are always going to be lower cost. But from the standpoint of our ability to be able to support the market, what we've done is our typical default says for vehicle bridges, we've got a modular approach, and we in fact provide those as beam bridges, rolled beam or welded plate girder in the case of the longer, usually over 100 feet is from 100 up to 200 feet in clear span will end up being a welded plate girder. So the modular approach lends itself, in this case, this shows a rural 24-foot travelway on a rural county road in Idaho, where it's been asphalted over, and typically up until what I'm going to be presenting in a few minutes, what we've had is a roll form galvanized steel deck surface set over rolled beams and welded plate girders. And the modules end up, depending on what the width is, but it may be a 3 or a 4 module system that ends up being delivered out to the site and just lifted up and set on the abutments. Again, in the case of pedestrian bridges, depending how big, whether it's mama bear, baby bear, or papa bear, but they're again in modules that are essentially clear span modules that would bolt together In the case of this one, this was about 250-foot clear span, and it came in five modular sections. Still going to get it one of these days. So again, modular steel bridges. What are the common features and benefits as we define them? Is their full bolt-together construction. Again, in the case of this shows lifting one of the modules into place and setting it on abutment. This overall, this ended up being, or is, a 75-foot bridge. It was a single lane, 2-module bridge, and literally got set in 3 hours off of the back of 2 semi-tractor trailers, lifted it right up onto the abutments. Now, they weren't driving across it in 3 hours. Literally, they were driving across it the next day, though. Again, they can be big. This is shows a welded plate girder. Again, modular. It was 120 feet long. Extremely heavy load rating. This one ended up having an off-road 80-ton load rating to it, so that's why it took welded plate girders, and they were a bit beefy. All of these are weathering steel. Again, we can paint them just like Bill was pointing out, but typically, again, our pre-engineered standards, we default to all weathering steel, and if somebody wants it painted, we'll blast it and paint it for them. Again, configured for asphalt, gravel, or concrete roadways. They're lightweight steel modules, and again, lend themselves much better because there is not a concrete deck already pre-poured or pre-applied on each of these modules. So these are relatively low pick weights in here, and typically in the range of anywhere from 15 to about 30,000 pounds typically on a module. What we started to look at when we took that very rural steel deck, steel framed bridge design and said, how can we really apply that to county bridges that with an application that, one, has potentially a higher average daily traffic count across it than a typical private owner bridge that might only drive across for access to his or her ranch or properties maybe 4 or 5 times a day. And make it low cost, keep that same sort of focus out there for simple to install, low cost, quick turnaround, etc. So this is what we were essentially looking at, is say, have a low-cost design for these low average daily traffic counts. Now, what is a low count? Is it 200 traffic a day? Is it 1,000 traffic a day? Well, what we found when we went down and got pre-approved for the Safe and Sound project in Missouri, that's just replacing about 800 of their bridges down there. Well, their low ADT threshold was less than 1,000 a day. And then they said between 1,000 and 2,000, they were still requiring an asphalt overlay on a concrete deck surface. So again, state by state, county by county, there's different definitions for low ADT, but we're essentially looking at in that 1,000 to 2,000 a day. A simple installation. Is it a design, or will it be a design that essentially can be approved by essentially any and all DOTs if they're looking at being able to truly help and support the counties with a low cost, quick to install, which usually also means low cost installation? And the answer is, I think, for the most part, all the state DOTs are supportive of trying to help out the counties, even though there's, in many cases, especially in Montana, in Helena, the Montana DOT has a truly different mission out there than what Carbon County might have with only 600 people when it comes down to the fact of money to spend and again, value. So again, from the DOT acceptable design, it's been brought out. They wanted a smooth road surface, something that that there's not a lot of transition bumps in if it's a panelized or a modular system. It's got to have TL rated guardrail systems, and it's to LRFD requirements today, which again, through all, I believe all 50 states are supposed to have adopted by now. But when you really get out there, there's still sites and installations that are getting allowances to get around LRFD, especially in wood bridge applications, in some of the steel modular approaches. Forest Service, et cetera, has been somewhat tolerant for bypassing or allowing non-LRFD design. And then what we're really looking at is to say, especially for counties, is to sit there and eliminate that center pier. How can we get cost-effective spans in there? So what we essentially did is said the best of both worlds. We want a concrete road surface, and we want the modular steel frame. So what's come out of a lot of the industry feedback is, boy, folks like the modular approach to the structure, but can we get down to lightweight deck panels? Actually panelized concrete decks that do give us smooth transition between each of the deck panels and or no transition between deck panels. Essentially simple grouting. Is it something that requires, again, formed up concrete pores in there? And if we can eliminate the formed concrete pores and just get down to simple grouting of any joints, then that's a real benefit. Full width deck panels, so there's no center joint in a standard double lane bridge, was again one of the requirements. Side mounted rail systems, if possible. It's not saying side mounted rail systems are better from a crash test than a top mounted rail system, but if you're talking a full width deck panel, if you got a side mounted rail system, to get that same 28-foot travel way in a typical double lane bridge is you're going to be essentially almost 2 feet narrower on the panel if you've got a side mounted system. So it's going to be easier to lift and install. It's going to be lower cost. And essentially, if you're sitting here designing something that can be pre-engineered and can go out into the field and installed cheaply, low cost, is you got to sit there and go for that 80% of the market out there. And so what was fed back to us is go standard double lanes in the 24, 26, 28 foot roadway width. It's not saying that there's not a heck of a lot of double lane roads in Indiana that are not or aren't 30 and 32 foot. But essentially what we've done is sit there and said, let's focus over here on the bulk of the older roadways with single and double lane. So the modular steel frames again to sit there and get the low pick weight, lightweight, double beam frames. I'll show you again why in the modular approach to sit there and keep 2 beam modules, which again, you could probably, or no probably to it, you could engineer out and have fewer beams, but in the modular approach for transportation, to be able to load it on a truck, get it cost effectively out to a job site, having 2 beam modules that can just be set off and set right onto the abutments are the cost effective approach, and to sit there and eliminate all field welding. Because again, if you're sitting here field welding, depending on what you're field welding, on a steel frame, it may require a certified welder. So if we can eliminate all the field welding, and sometimes it adds some incremental cost to have a bolted splice, a bolted flange, a bolted arrangement, but again, from the standpoint of quick installation out in the field, all bolted modules. Again, if cambering's required because of clear span length, then they're pre-cambered, and it was a requirement out here for a low-cost design to have essentially a composite deck loading and to be able to utilize standard trucks. So what the industry, I think, in general is going for are these what I'll call panelized deck systems. We started a number of years ago to sit there and have panelized deck systems that weren't full width panels that came in here. In other words, for the 24-foot travelway, that they were the full 24 width. This shows some of our double deck system that we'd started out with that required, they were essentially 12 and 13 foot panels that went together out in the field. A little bit more installation, a little bit more cost than preferably for the full width. So again, what we're talking about is looking at a maximum, trying to keep that crane capacity down, so delivered weights of less than 24,000 pounds apiece. You might sit there and say, well, why 24,000 pounds? Well, because again, to be able to deliver these out to a rural county is you've got 2 deck panels to be able to be on one standard over-the-road truck. About 48,000 pounds is very easy and very cost-effective for being able to truck things across quite a bit of distance. So that would allow double panels to be able to go on each truck. Panel length, if you're talking about 24 or 28 feet wide on the panel, is from a width. The length itself would be less than or right at 8 feet. So again, they can use the standard trucking without getting into over width trucks, and also it keeps that crane lift capacity down. The design for roadway quality, there's a number of different ways to be able to panelize a concrete deck. But if you'll key it or match cast the joint to joint or the panel to panel joints, then essentially what you're doing is, if it is truly match cast, there is it's a bumpless transfer from panel to panel in there. And focus on being capable of county crews to be able to install it. It's a simple installation. If it's truly just bolting together, leveling, setting on abutments, you can sit there and either use your county crews to be able to install, or a much more low-cost excavation contractor that can sit there and set a bridge versus have to go out to a trained bridge contractor. So again, in trying to focus and keep it down to a 3 to 6 day installation from start to finish. Now, if you're pulling out an old bridge and putting in, the 3 to 6 days doesn't include the demo and the pull out of the old bridge. It doesn't include the demo and the pull out of center piers, if there's center piers out there, and now you're clear spanning. Okay, but the only skills that this system was looking to try to design around is leveling, safe lifting, bolting, and grouting. And generally it's not saying that each of you from a county standpoint have county crews that are sitting around twiddling their thumbs and you want to use them to install your bridges. But what we have seen is especially in the Rocky Mountain and Pacific Northwest, is there are seasonal times where county crews aren't fully absorbed and utilized, and to be able to take 3 or 4 of the crew and go out and install a bridge that they've already been able to contract with and have on site makes it a good low-cost solution. So here's a typical panelized deck system, and this happens to be again, this was the double panels versus the full width panel on this bridge. It's a 120-foot long bridge set up in Alaska. But essentially, This is a normal picture. I challenge anybody to sit there and show me where the panel-to-panel joints are. And the reason is this is a match cast joint that's pulled up, and when you sit there and you grout in that match casting, by the time it's pulled up, it's essentially a perfect seal. There's no bump going across as you're going across that bridge in either way. Like you would typically have some level of transition panel to panel if it was a concrete tri-deck or even if it was a bulb T, unless you put an asphalt overlay to it. So what's actually holding the deck down and making this a composite structure are grout pockets that are all the way down. You'll see these. You can tell where it has been grouted in, and there were weld studs put on top of the beam in there for the panels to sit over and then grout in. This is a little bit further away picture as this bridge is being installed. Again, I'll sit there and show that in this case it didn't require a TL rated system, and essentially this is kind of a modified side rail that FHWA, this actually is on tribal land up in Alaska, but FHWA did the approval process on it, and it's a little bit different side rail mounting system. But again, modular steel frames, I'll show a picture here shortly where again, this is six girders that went across for this 120-foot bridge. And low-cost abutments, when I say low-cost abutments, these are still, whether it's a piled abutment or if it's a poured-in-place abutment, the dead load that you're supporting is significantly less on a modular steel bridge with a concrete deck than what it's going to end up being if you're using either pre-stressed or precast girders. Again, this is just to show a little bit of a close-up of what I'll call self-aligning keys in these match cast panels. You'll see that the key doesn't go all the way out to the end of the panel. It starts and it draws up because it's a tapered key. So when this is actually showing a few of the panels for a typical bridge out in the precaster yard. And essentially what draws panel to panel up is in here across the bridge. There'll be 4 post-tension cables that are run in a PVC line, and you just sit there after you set 1 panel, 2 panels, and 3 panels, and you just tension it right on up, snug it up, and that cabling isn't there for any structural strength after the installation, because once the grout pockets are grouted in, that's your strength right there, and the cable can just go away in perpetuity from there on out. And again, at the precaster is you just sit there and they'll typically hydroblast to have a good pre-finished road surface. In this case, these weren't crowned panels. Typically is the standard precast deck panel would in fact be crowned and very suitable. Typically it's about a 9-inch deep in the center and 7.5-inch deep at the outer edge, and can provide the primary road surface without asphalt overlay. Again, the modular frame, this kind of shows, generally speaking, they're in this case, it was a welded plate girder, but it could be a rolled beam. They're set up in 2-beam or 2-girder modules so that they set very well and they transport very well on a truck. So actually in this case, they went by truck and then by barge up to this application, but I don't think you've got to worry too much about having to barge bridges into any of the county applications here in Indiana. This actually shows, again, it's a 3-module line. These are the bolted diaphragms. I really should have used a much smaller bridge, which would be a typical rural county bridge for This presentation, I'm not trying to just say, boy, this is only a good fit for 100, 140 foot bridges, but typically if you can do something big, then you can also make it certainly work in a smaller and downsize it. So again, there's 3 modules, and it was a bolt together splice out here to where again this whole modular approach comes in, and then we just start placing the deck panels out here, and the deck panels aren't even required to be placed with a crane, because you can, once you place a deck panel over here, then you can walk if it's an excavator or if it's a dozer, you can just walk your panels right on out and just be setting them as you cross all the way across that bridge, whether it's a little 40-foot span or whether it's a 120 or 30-foot span. Again, this sits there and shows this was a 24-foot travelway. The picture doesn't show it real good, but there's actually, you'll see some of the post-tension cables that are used to pull up the deck panels right up here. The cable is the full width of the bridge, and you just sit there and you snake the cable through the panel ductway, and it's a very simple procedure, and it's not something that anybody should or would get intimidated by in the installation. This shows a typical grout pocket with the shear studs that are in there. In the case of this particular bridge, these shear studs were shot out in the field. That isn't the standard. The standard is that they would be shop fabricated and shot on the shop floor so that each of the grout pockets have their shear studs installed. And generally speaking, this shows a 65-foot panelized deck bridge in Wyoming. Again, weathering steel construction, very simple guardrail over here for Wyoming DOT. Didn't require a specific rating on this system since it was a low-speed bridge application and very low ADT. But for a typical 40 to 50-foot bridge is, from start to finish, is 3 to 4 days. 4 days, if you were using a county crew that hadn't done it before, then you'd add another day on there. They take the video that we would sit there and provide with the step-by-step instructions, and you can walk right through it and literally be driving across that bridge in 4 days from when you started to set it. On the 75 to 125 foot, it's a little bit more involved, for one, because typically you're going to have a bolted splice in the center. It takes some larger crane capacity, and it's just a little bit more involved system, although it's based off of the same simplicities of the 40 to 50 foot bridges, and they'll be installed in 6 to 7 days. The deck can be crowned or flat for an asphalt overlay. If you're going to put an asphalt overlay, why have the increased cost of a crowned deck panel if you're going to sit there and take your road wear and beating on the asphalt anyway? So again, can be either crowned or flat. A typical 50-foot clear span, 50 to 60 foot, would be delivered on 5 trucks. And you sit there and you say, well, that's, 5 trucks is more cost than 4 trucks, but it's a heck of a lot less cost than 6 or 7 too. Just wanted to give you a feel for what the logistics are of this. That's everything is delivered on 5 trucks. It's staged up there so that, again, if you were using your own county equipment or if you were using a contractor out there, he sits there and picks those bridge frames off, and then on day 2 we could sit there and deliver the panels, and he sets the panels right out onto the bridge frames and walks them across the installation. The real beauty of this is there is no on-site forming and pouring of concrete. Yeah, there's some grout, and it just takes a little grout mixer to sit there and mix up the grout to go into the pockets, and I am simplifying a little bit. There's a few other steps for how it's grouted below the deck to be able to make that an intimate joint between the concrete deck and the actual steel beam or steel girder, but it is an intimate joint in there. So again, there's no flexing of the deck and interaction between the deck and the girder there. You know, kind of overt benefit. What is the benefit of this? It's not saying it's the absolute pure answer for each and every rural bridge that's out there, but the ones where you really need to be able to install quickly, you don't want to end up having concrete forming out there on site, and the time as well as the cost element of that. If you want a simple system that very conceivably you can use your own county personnel to put in, then this system's got some real benefit to it. The real reason to believe is it's been installed, it's out there. There's a number of panelized systems that are in place across the country, not just Roscoe Bridge. So the reason to believe is this isn't pie in the sky, it's an actual product. And you can go visit installations if you need to. And, you know, dramatic difference, well, it is. It's different from the traditional cast-in-place deck system. But outside of that is it's not rocket science. It's just kind of taking the ABCs of simple, quick, efficient, and mixing them together. And depending on what the application that you've got, it may be the most cost-effective solution for you. Not saying it is in every case, but I am saying in many cases, especially where speed of installation and simplicity, again, no field welding, in cases where, especially like out in Montana, where we've got fire seasons, et cetera, take some of that seasonality out of being able to put bridge systems in. Questions?
When you put these panels together and you have an overlay on top of the panels, have there been any longitudinal tracks developing where the panels are connected together?
And the answer to that is right now, we have not put these in where, as far as I know, there's an asphalt overlay. Actually, the picture on that bridge that was just installed up in Alaska 18 months ago, they're putting an overlay on right now. And so we'll have that data point. Missouri DOT, when they approved it for the Safe and Sound project, didn't have an issue with it after we sit there and went through the whole design book and exactly how those panels made up. With that match cast keying, there's an absolute intimate panel-to-panel joint, so they didn't feel uncomfortable at all about it. But being very open with you, there's not a whole lot of data out there right now that I can refer you right to. Yes, sir?
How does it play the skew?
The skew basically comes in, if it's a double skew, then there are two unique end panels. Essentially, right now, the standard engineered panel is an 8-foot 4-inch long panel, and essentially those are the bulk of whatever clear span is made up of those 8-foot 4-inch panels. If it so happens that it's an even multiple of 25 or 8-foot 4-inch, then there's no unique end panel. Most bridges would have one, if it's non-skewed, would have one unique end panel to make up the difference from that even multiple of 8-foot 4-inch. In the case of skewed bridges, then there's going to be two unique skew ends on each bridge.
How do you prevent the leakage from the panels to not go to the beams underneath?
And
All that, you know?
yep, and that's a great question. What in that match cast joint, before the panels are pulled up, there's an epoxy grout essentially that's put in there, and it's very judiciously put in so that when you tension it up and pull the panels together, it's an absolute watertight seal in there. Yes, sir.
Are the panels and the stringers considered composite design?
They are. After you sit there and again, once it's set in place and the grout pockets are poured, then it is a composite deck. Yes, sir, again.
What do you use for spacer underneath to fill your grout?
There's a 1x1 elastomeric pad that goes on top of the beam, and essentially from grout pocket to grout pocket, you sit there and you grout in there, vibrate in that grout so that it fills between that 1 inch space between the panel bottom and the beam top. So you've got 1 inch of.
Continuous grout pad
Yes, sir.
on top of the beam, full length of the bridge?
Yes.
All beam?
Excuse me.
Every beam?
Every beam. Yep. And again, what captures that and keeps it in is a 1x1, about a 40 durometer elastomeric. It's just like bearing pad. Other questions? Visit us at roscoebridge.com, and we'd love to sit there and see if we can add some value for you, whether in fact you're a consulting engineer, whether you're Indiana DOT, or whether you're a county, somebody who needs a bridge out in the county. Thanks a lot.